how to access our website. Go to any browser and type search creators. Click on the first link. Now you have entered our home page where 50k plus study materials are available along with 1000 plus project ideas. We have 10 plus expert members in our team and we also support 50 plus engineering domains. In navigation bar, select University Study Materials. There are 3 streams available: computer science, information science and artificial intelligence and data science. For now, we will click on computer science. Now we will be able to access all the study materials of different subjects of different semesters.
Everyone, welcome back to Search Creators YouTube channel. Today we are going to explore about the second module in cloud computing, which is virtual machines and virtualization of clusters and data centers. Before moving into module 2, make sure that you have downloaded our notes from our website. The website link is in the description box. Make sure you download the notes and then watch this video because you will understand more clearly. The first concept in module 2 is implementation level of virtualization. Virtualization. Virtualization allows multiple virtual machines, which are VMs, to run on the same physical hardware, improving resource sharing, performance and flexibility. What it means that virtualization allows multiple virtual machines to run in a single computer. By this, improved source sharing, resource sharing, performance and flexibility can be achieved. Virtual machine, like it creates a virtual environment in a single computer. By this, in a single computer only, multiple virtual machines can run. It improves resource sharing, performance and flexibility. It enhances system efficiency by separating hardware from software. Virtualization enhance the efficiency, system efficiency by separating hardware from software. It has gained importance in distributed and cloud computing. Like virtualization has gained more importance in distributed and cloud computing. Next, we are going to look at levels of virtualization implementation. Virtualization can be implemented at various operational layers of the system, including, here there are two diagrams. A is traditional computer, B is after virtualization. In traditional computer, we can observe application, host operating system, hardware. After virtualization, we can observe two applications, two guest OS, virtualization layer, hardware running the host OS. In this diagram, we can observe the architecture of computer system before and after virtualization, where VMM stands for virtual machine monitor. Next, there is another diagram of virtualization ranging from hardware to applications in 5 abstract levels. Those 5 abstract levels are application level, library level, operation system, hardware abstract layer level, and instruction set architecture level. These are the 5 abstract levels ranging in virtualization. Instruction set architecture ISA level. Here we are going to look at instruction set architecture level. Virtualizes the instruction set of the host machine to emulate different processor architectures. Example, running MIPS code on x86 machine. Virtualizes what the instruction set architecture level does is it virtualizes the instruction set of the host machine to emulate different processor architectures. For example, running MIPS code on an x86 machine. It uses code interpretation or dynamic binary translation for better performance. The instruction set architecture level uses code interpretation or dynamic binary translation for better performance. Next is hardware abstraction level. Virtualizes hardware resources like CPU, memory, input-output devices to allow multiple users to utilize the hardware concurrently. What the hardware abstract level does is it virtualizes hardware resources like CPU, memory, and I/O devices to allow multiple users to utilize hardware concurrently. Like hardware resources like CPU, memory, and I/O devices, it virtualizes it and allows multiple users to utilize hardware concurrently. Example is IBM VM370. Modern example is Zen Hypervisor for x86 machines. Next is operating system level. Creates isolated containers on a single server to allocate hardware resources among users. Commonly used in virtual hosting environments and server consolidation. Like what operating system level does it? It creates isolated containers on a single server to allocate hardware resources among the users. Where it is used? It's commonly used in virtual hosting environments and server consolidation. Next is library support level. Virtualizes the communication link between applications and the OS through API hooks. Examples include Wine, which is Windows application on Unix, and VCUDA, VCUDA, GPU acceleration within VMs. Like examples for the library support level are Windows application on Unix and GPU acceleration within VMs. Next is user application level. Virtualizes individual application or processors, often called processor level virtualization. It virtualizes individual application or processor, often called as process level virtualization. Examples include the Java Virtual Machine, which is JVM, and Microsoft .NET CLR. Other approaches include application isolation, sandboxing, and application streaming, where the application is isolated from the host OS for easier distribution and removal. Here you can observe sandboxing. Sandboxing is the place where web users deploy their project and it cannot be accessed by others. Like some error calculations can be done in sandboxing without leaking any important details or features to the outside world. Next is purpose and applications. Virtualization improves resource utilization, enables running different OS and applications on the same machine, and simplifies the management of distributed systems. Virtualization improves resource utilization, enables running different OS and applications on the same machine, simplifies the management of distributed system. It plays a key role in enhancing distributed computing, cloud environment, and legacy software support. Legacy software support in the sense ever evolving software support and cloud environments and distributed computing. It plays a key role in them. Next is relative merits of virtualization approach. Comparison factors like higher performance, application flexibility, implementation complexity, and application isolation are some comparison factors. Merit representation is number of x's in a table. 5x equal to best, 1x equal to worst. Next is performance consideration. Hardware and OS level virtualization. Like higher performance but expensive. They provide higher performance but they are expensive. Next is user level virtualization. Most complex in terms of application isolation. Next is ISA level virtualization. Best application flexibility is given at ISA level virtualization. Next is VMM design requirements and providers. In this definition and role of VMM, VMM, which stands for Virtual Machine Monitor, is a layer between hardware and the operating system. It manages hardware resources and capture program interaction with hardware. It enables multiple OS instances to run on a single set of hardware. Like this is the definition and role of Virtual Machine Monitor. The requirement of VMM: identical execution environment. Programs should run as if they are on a real machine. Like programs should run like the programmer should feel like if they are really running on a real machine. Minimal performance overhead should not significantly slow down program execution. Like the program execution must not be slowed down. Full control over the system resources. Program should only access explicit allocated resources. Like full control over the system resources. Program should only access explicitly allocated resources only. Next is performance consideration. Virtual machines share hardware leading to resource contention. Timing dependencies and resource availability may cause minor performance differences. Like dependencies and resource availability may cause minor performance differences in the virtual machine. Traditional emulators or simulators offer flexibility but are too slow for real world use. Like traditional emulators and simulators give flexibility but they are very slow for real world usage. Efficiency is ensured by executing most virtual processor instruction directly on hardware. Efficiency is ensured by execution of most virtual processor instruction which is directly on the hardware. Next is resource control by VMM. Allocates hardware resources to program. The virtual machine allocates hardware resources to the program. Restricts unauthorized access to unallocated users. Like it restricts the authorization of unknown users and it only gives authorized persons to access the resources. Can reclaim allocated resources under certain conditions. Like we can reclaim allocated resources under certain conditions. Next is challenges in VMM implementation. Some processors, for example x86, lack full virtualization support. What is the solution for this? Hardware assisted virtualization modifies hardware to support virtual machine requirements. Next is virtualization support at the OS level. Role of OS level virtualization in cloud computing. Cloud computing relies on virtualization to shift hardware and management costs to third-party providers. We know that while using cloud computing, many third-party application will be included in that. By this, cloud computing relies on virtualization to shift hardware and management costs to third-party providers only. Two major challenges: dynamic resource allocation, slow VM in instantiation. Dynamic resource allocation, scaling CPU resources based on demand only, and slowly VM instantiation means fresh VM boots take time and lack awareness of application state. Like fresh virtual machine boots take time. By that, lack of awareness of application state is caused. Why OS level virtualization? Hardware level virtualization is slow and inefficient due to redundant VM image storage and performance overhead. Why OS level virtualization is needed or why it is necessary? Hardware level virtualization is slow and inefficient due to redundant VM image storage and performance overhead. OS level virtualization creates multiple isolated virtual execution environments, which are VES, or containers within a single OS kernel. OS level virtualization creates multiple isolated virtual execution environments or containers within a single OS kernel. VEs function like real servers with their own processors, file system, user accounts, and network configurations but share the same OS kernel. The VEs function like real servers only with their own processors, file system, and user accounts and network configuration but they share the same OS kernel, also known as single OS image virtualization. It is also known as single OS image virtualization. Next, we are going to look at the advantages of OS level virtualization. What are the advantages? Fast startup or shutdown, low resource use, high scalability, state synchronization between VMs and the host OS. What it means is it allows better application state awareness. Efficiency through resource sharing. PEs can access most host resources without modifying them. Like they can access most OS resources without the need of modifying them. Overcomes slow VM initialization and application state unawareness in cloud computing. Like it overcomes slow VM initialization and application state unawareness in cloud computing. Like this is one diagram representation in which we can observe the open VZ virtualization layer inside the host OS, which provides some OS image to create VMs quickly. You can observe that in this figure. Next is disadvantages of OS level virtualization. Same OS requirement. All VMs on a single container must belong to the same OS family. Like Windows based VMs cannot run on Linux host. Like Windows based virtual machines cannot run on Linux. User preferences issues. Some cloud users require different OS types, limiting flexibility. Like user preferences issue can be observed in this. Like some cloud users require different operating system types. By this, it limits the flexibility. Next is resource duplication problem. If each virtual machine has a full copy of system resources, it leads to high storage and performance costs. Resource duplication problem means if each virtual machine has full copy of system resources, it leads to high storage and performance costs. Next is implementation consideration. In that, creating virtual root directories. First is duplicate resource for each VM, higher cost. Second is share most resources and create private copies on demand. Like it is a preferred approach. OS level virtualization is often a second choice due to its limitation compared to hardware assisted virtualization. OS level virtualization is always a second chance. Why? Because due to its limitation compared to hardware assisted virtualization. Like compared to OS level virtualization, hardware assisted virtualization is more preferred. Next is virtualization on Linux and Windows platform. We are going to look at Linux versus Windows virtualization. Linux-based OS level virtualization is well developed, while Windows-based OS level virtualization is still in research. The Linux kernel provides an abstract layer for handling hardware, often requiring patches for new hardware support. Most Linux platforms are not tied to a specific kernel, allowing multiple VMs to run on the same host. Windows OS virtualization tools are still experimental, with FVM being an example for Windows NT platform. Here we can observe that Linux-based operating system level virtualization is well developed, while Windows is still in research. Linux kernel provides abstract layer for handling hardware, often requiring patches for new hardware support. Most Linux platforms are not tied to a specific kernel, like they are not tied up to a specific kernel. By this, they allow multiple VMs to run on the same host. Windows OS virtualization tools are still experimental, like Windows OS virtualization tools are still in experimental phase, with FVM being an example for the Windows NT platform. Next is virtualization support on Linux platform. OpenVZ. OpenVZ is an open source container based virtualization tool for Linux. Like it is a open source container based virtualization method tool for Linux. It modifies the Linux kernel to support virtual environments, resource management, checkpointing, and live migration. Virtual environment means each VPMs function like an independent Linux server with its own processor, users, and virtual devices. Resource management means controls CPU, disk space, and memory allocation. Next is checkpointing and live migration. Save the virtual machine state to a file for quick transfer and restoration on another machine. Next, we are going to look at one more table. In this table, we can observe virtualization support for Linux and Windows NT platform. You can go through this, like virtualization support for Linux and Windows NT platform can be observed in this table. Next is resource management in OpenVZ. Two level disk allocation. First level is admin allocates disk space from VMs. The first level is the admin allocates the space for VMs. Second level is VM admin assigns disk space to users. Two-level CPU scheduling. In this, first level is OpenVZ decides VM priority. Second level is standard Linux CPU scheduler manages tasks within the VM. Second level is standard Linux CPU scheduler. Like there is a Linux CPU scheduler which manages the tasks within the virtual machine. 20 plus resource control parameters ensures optimized VM usage. Like 20 plus resource control parameters ensure optimized virtual machine usage. Next is middleware support for virtualization, which is library level virtualization. Library level virtualization is also known as user level application binary interface, which is ABI or API emulator. The library level virtualization is also known as, or it is called as, user level application binary interface, which is ABI. This type of virtualization can create execution environments for running alien programs on platform rather than creating a VM to run the entire operating system. This type of virtualization, they develop an environment, execution environment for running foreign or alien programs on a platform rather than creating virtual machine to run the entire operating system. API called interception and remapping are the key functions performed. This section provides an overview of several library level virtualization systems. API called interception and remapping are the key functions performed in this virtualization. This section provides an overview of several library level virtualization systems, namely the Windows Application Binary Interface, which is WABI, LX Run, IX Run, Wine, Visual Main Win, and VCUDA, which are summarized in the table 3.4. The table 3.4 can be observed here. In this table, middleware and library support for virtualization can be observed. Here, in example 3.2, the VCUDA for virtualization of general purpose CPUs. We can observe CUDA is a programming level. The different information about the CUDA we can observe here, and there is also one figure representing the basic concept of VCUDA architecture. CUDA is a programming model and library for general purpose CPUs. It leverages the high performance of the GPUs to run a computer intensive application on host operating system. Like it leverages the high performance of GPUs to run compute intensive application on host operating system. However, it is difficult to run CUDA application on hardware level VMs directly. vCUDA virtualizes the CUDA library and can be installed on guest OSs. Here in this figure we can observe the host OS and guest OS, and the basic concept of vCUDA architecture can be observed in this diagram. So this is all about the first concept in the module 2 of cloud computing, which is implementation level of virtualization. I hope you have downloaded the notes, and holding the notes you have watched this video. I hope you understand well. Stay tuned for further videos on module 2. Thanks for watching. Please like, share and subscribe to our channel.